In this video, we're going to be looking at points moving around a circle with changing velocities and position. Let's take a look at this circle right here. So we're given that the time at this point it's there at 0 seconds and 6 seconds, while it's here at 3 seconds. We also know that the radius of the circle is 4. So it's all very important information. So as we would in the last video, set up an equation, we would at first think to do our equation, and we would have our radius, which is 4, times cosine, and I'm just going to leave that blank right now, and we'd have our y of t equals 4 sine, and I'll also leave this blank right now. So what goes here? Because it's not going all the way around the circle, it's not going all the way like that. Instead, it's going here and then back. So let's try graphing. So we know, so we're going to call this function theta versus time. So we're going to have t here and our angle theta there. We know that the farthest we want this to go from here, from our t equals 3, is pi over 2. So we're going to set that to we're going to have our top be pi over 2. However, we want our bottom to be 0 degrees. So we know that over the span of 6 seconds, it starts at pi over 2, it goes down at 3 seconds, and it's back up at 6 seconds. So this graph roughly looks like this. So now what is this graph? Well, we know our mid-height would be pi over 4, because it's halfway between pi over 2 and 0. So theta of t is equal to our pi over 4, our mid-height, plus the deviation or amplitude, so pi over 4 again, and this is a positive cosine graph, pi. Now we don't know necessarily at first what this is, so let's look at BP equals 2 pi, right? So our p in this situation is 6 seconds. So B6 equals 2 pi, giving us a b value of pi over 3. So this would go right here. And now we're going to input this function right there. And this would graph this movement on this circle. If you feel comfortable, please pause the video and give this one a shot. If not, take a look. So we're going to first put our circle here. So we're given that at time 0, the bug named Fuzzy is at 0.6 on the circle. And we're given the radius of the circle as 36. So we're given the radius of the circle as 6. So this is our starting point at t equals 0. Then we know that the bug goes from 0.6 to 0.6. That is its movement. So it takes from here, we'll be here at t equals 0 and t equals 6, and here at t equals 3. Alright, so now we're going to look at the parametric equations. So first we're going to do the exact same thing. We're going to start with x of t. We're going to equal that to our radius times cosine. And we'll just say theta t for now. And y of t would be 6 sine. So now we're going to, we know that the graph goes from here all the way down back here and then returns in 6 seconds. So let's graph this. So we're going to have our theta versus time graph. So we know that the entire thing is 6 seconds. We know the period is 6 seconds. So now we know that, and also we know that top of the period is going to be pi over 2, and the bottom is going to be negative pi over 2. So we know it's going to start at its max, go to its min, and then end at its max. So if you couldn't tell already, this is forming a positive cosine graph. So we know that our mid height is going to be 0, so we don't have to take it into account. So we know it's deviating pi over 2. And now we have to look at our BP. So it's the same situation. BP equals 2 pi. Our period is 6, giving us a B value of pi over 3. And that will graph this function. In this example, I encourage you to try it on yourselves. Alright, so now we're going to set up our circle like normal. However, this time we don't have the starting position. We just know that it starts 20 degrees below the x-axis. And we know that the circle has a radius of 7 because we are given its equation. So we know that the bug fuzzy starts here at time 0 and returns here at time 8. And we know that bug ends at negative 7, 0, and it'll be here at time equals 4. So, first step is to say that x of t is equal to our radius times cosine, we'll say theta t once again. And then y of t is equal to 7 sine theta of t. So we're going to do the exact same thing. So we know that its max is going to be pi, and we know its min is going to be 20 degrees. So how do we get 20 degrees to radians? Well, we know that 180 divided by 20 is 9. Therefore, we're given that 20 degrees is pi over 9. So we know it'll be negative pi over 9. We also know that the entire thing takes 8 seconds, the entire trip. That's the entire period, and 4 will be half period. So we know that it starts at its min, goes to its max at pi at 4 seconds, and returns to its min at 8 seconds. So this graph, if you can't tell, is a negative cosine graph. as it begins at its min, goes to its max, and returns to its min. So now we have to find the mid-height. Well, it's actually a lot simpler than it seems. We know that the entire distance between pi and negative pi over 9 is 10 pi over 9. Therefore, if I say the mid-height is 4 pi over 9, if you add 5 pi over 9, you'll get pi, and if you subtract 5 pi over 9, you'll get negative pi over 9. So now we have to find the equation. So we have theta of t equals 4 pi over 9, which is the mid-height, plus 5 pi, minus, because it's negative cosine graph, minus 5 pi over 9 cosine. And now what is the b value? Well, we know bp equals 2 pi. b times 8 equals 2 pi, thus b is pi over 4. So cosine pi over 4t. And you would plug that in for theta of t, and you would get your graph of this. So we're going to have one more example. In this example, it's pretty much the same situation, so I encourage you to try, so feel free. In this situation, we're going to have our circle like always, except we know a couple different pieces of information. So instead of being below the x-axis, this time it's above at a 45-degree angle. So a little nicer numbers. And we know that the circle has a radius of 9 because of its equation that's given. So we know that it starts at this 45-degree angle point, and it'll be here at time equals 0 and time equals 8. And that it will go to negative 9, 0, and it'll be there at time equals 4. So this is again with fuzzy. So we're going to set up our x of t, which will be equal to our radius, which is 9 cosine, we'll say theta of t, and y of t equals 9 sine theta of t. So now we're going to graph our theta of t graph. We have our time on the x, theta on the y. We know the entire thing takes 8 seconds, or 8 values of time. That's our period. So we know its farthest is pi, and its min is pi over 4, which is equal to 45 degrees. So we're going to start at our min and end at our min. While we'll be at pi at 4 seconds. So this forms a negative cosine graph. So we need to find our mid-height. So we know that 3 pi over 4 is our total distance. And we know that half of that is equal to 3 pi over 8. However, we aren't done. We know that that's just saying that's half the distance, but we are shifted up pi over 4. We have to add 2 pi over 8 to that, giving us 5 pi over 8 as our mid-height. So we get 5 pi over 8 as our mid-height with deviation of 3 pi over 8. So now we can set up this equation. So theta of t equals 5 pi over 8 minus 3 pi over 8 cosine. Now we have to find our b value. So we know bp equals 2 pi. Our p is 8. And therefore b is pi over 4. And that graphs this function. There'll be more examples in the description. Feel free to like and subscribe.